Good morning, doctor. My name is Chajiwai and my matrix number is 18110729. Today I'm going to present ANT335 System Design IDP1 and my title is Smart Electric Wheelchair System. My group mates are Manoj Kiran, Muhammad Arif Zahin and Mio Arif Azuwan. And Dr. Teo Wheelchair is our mentor for IDP.
I want to talk about introduction. For the overview, since the aged and the disabled often have decreased senses and judgment abilities, it is often essential to assist these abilities and their physical abilities. There are several functions that are distinct from the concept, among which is that you can use instrument electric wheelchair. At the first, it can control movement of wheelchair during emergency condition and more convenient on helping to move the wheelchair. Secondly, it can receive an emergency alert, receive alert from emergency button, checking on wheelchair position and tracking users simple healthy history and vital sign. And then lastly, it is provide IoT and big data for system. For the background, a smart wheelchair aim to provide aid to those disabled and physically aged person, and then use the application to control the movement and is more convenient is helping to move the wheelchair and has an emergency button to one when the wheelchair is damaged. And lastly, the dynamo electric generator is also used to power to reach the goal from SDG. Goal number 7 is affordable and clean energy.
A very good day to dear lecturers and dear panels. I am Manoj Kiran. I'll be talking about problem statement, objective, and lastly is the scope. For a problem statement, according to World Health Organization, 15% of the world population are disabled people. 2 to 4% out of it have difficulties in walking. So this has caused our employers to reluctant to hire them, and this becomes a barrier to those walking disabled people. And the current wheelchair on the market is too basic and doesn't has any advanced features. Next is the objective. We are going to design a new wheelchair which is contemporary design and is according to the Industrial Revolution 4.0. Other than that, we are going to incorporate Internet of Things into our wheelchair, and we are going to create a wheelchair where minimum human effort is needed. Other than that, we are going to fuse in renewable energy sources as part of the Sustainable Development Goal. For the scope, we are mainly focusing on those disabled people who have disabilities in walking. Other than that, we are going to infuse IoTs, and it can be controlled through the mobile app, and it will be very useful during any emergencies or even accidents since we can get notified. Other than that, we are going to use a rechargeable battery as our main power source for the wheelchair. Thank you.
Moving to chapter 2, need identification. In chapter 2, we start with 2.1, benchmarking. In this chapter, benchmarking, we have provided the table of benchmarking. Benchmarking is basically we take several products available in the market and we make a comparison based on categories that we have listed. And the category is first dimension, material, weight, loading capacity, batteries, warranty, power, driving range and cost. This comparison make us clear what is the need in our product. That's why we call it benchmark. After we have a look at the table of benchmark, we construct a table of customer requirement where based on the category that we have listed, we score the available product that we have choose, so that by the look at the score, we know which category have the highest mark and we can include it in our project or our created product.
So, I will continue to 2.2, design of market survey. This survey was done by using questionnaires. This questionnaire divided into 5 sections. First section is the personal information of the person with disability. Second section of the questionnaire is general overview. In this section, we ask questions to collect some general basic data regarding the person with disability. In the third section, we ask about the problems they face regarding the equipment they use. In fourth section, 6 solutions are suggested in this part and the newly invented function of the wheelchair. Last section highlights products within the opinions and requirements. The survey carried out using the method Google Form to collect data. The link of this form is distributed through online social media such as Facebook, WeChat, WhatsApp, and Telegram. This questionnaire is distributed to the group with person with disability. This method is very convenient because it saves time and cost, and it is distributed to respondents wherever they are. 52 responses have been collected for this survey. In personal information, we found that 47 out of 52 responses are persons with disability. In this session, we collected the data of gender and age of the respondents, and we also found that 44 out of 47 responses are persons with physical disability. In general overview, we collected the data of equipment that they use the most during daily life. Time taken to use the equipment mentioned above per day, do they use smartphone, and etc. All the questions in this session are multiple choice questions with one open-ended questions. In problem sections, we collected data such as malfunctioning of equipment, difficulties while using joystick, accidents while using the equipment, and etc. This can help us to understand what actually they struggling with. In the section of solutions, we use the Likert skill type of question on the survey. Total of 6 solutions are suggested in this part for the newly invented function of the wheelchair to solve the problem met by the user regarding IoT. 2 functions with the highest responses on agree and strongly agree will be added into respondent requirements sections. In respondent opinion and requirement, we are also using the Likert skill type of questions. In this session, we collected data such as lightweight, high weight capacity, low power consumption, and etc. 2 most voted functions in the above section will be included in this session. They will be more focused and consideration may be given based on the variable most voted on. By accomplishing this function of ranking, further process in design would be much easier.
For the chapter 3, we have to talk about the design specification. At 3.1, design parameter identification, we have 3.1, the calculation of important weight factor. This is important weight factor have a 9 characteristic, and if you went to detail about this, you can refer a report.
Moving on to House of Quality, HOQ. In this House of Quality table, we do a matchup of relationship based on the customer requirement and engineering characteristic. The relationship can be indicated in 3 types, which is strong, moderate, and weak. Based on this table, we can have the raw score so that we can get the relative importance wasting percentage, and we can rank each customer requirement based on its number of engineering characteristic. Moving on to the discussion of customer requirement. In this table of discussion, we discuss each type of customer requirement that are included in our project.
As for the product design specification, it is known as a smart electrical wheelchair system. It will alert people in case of any emergencies or accidents. As for the key features, it has an accident detection feature, and it even has an emergency button. It's a water and dust resistant wheelchair, and the power usage also is very efficient, and it's lightweight and durable. It weighs around 8 kilograms approximately. For the performance target, it has a high weight capacity and uses a low power consumption motor, and it's cheap and affordable. It's easy to use, and it uses only clean energy for power system. Other than that, you don't need much requirement or any knowledge, since we'll provide a quick user guide and also owner's manual. We target market is those people with walking disability, hospitals and health centers and so on. We will brand our wheelchair as SEWS. We assume that our manufacturing cost is 700 ringgit, but we recommend to sell it at 1000 ringgit. And our manufacturing spec, we will produce the wheelchair in-house, and those suppliers for the parts will be local suppliers. Thank you.
Chapter 4, Concept Generation. 4.1, Overview. The overview of this chapter, first we will look at physical decomposition, where we will dissect the device into smaller parts to get a better idea on the components of the project. Second, functional decomposition, where we will produce function structure. Third, functional basis. Fourth, systematic design. Fifth, function block. And sixth, function structure. 4.2, design goals and constraints. The main goals of this project is to help people with physical disabilities to move freely and become more independent. Second, we want to incorporate the element of IR 4.0, which is the Internet of Things, into our project. And third, we want to incorporate the SDG 7, which is affordable and clean energy, into our project. We have 2 main constraints in doing our project. First is cost. We have a straight fund, small fund, as we are student, because our project have several components that are expensive. Second, our project have a specific demographic user, it is difficult for us to reach this group to get the information that we need. 4.3 Data, information and knowledge. The data, what we want to look is the observation of the usage of wheelchair in the society, where we want to identify the trend, which type of the wheelchair that are well received in the society. The information and knowledge of this project basically cover the comprehension of the overall operation of the wheelchair by each type of the component. So by understanding how well the component works in this product, wheelchair, we can execute more details and we can create a better product, or we can create a good project.
So, I will continue to 4.4 functional decomposition. A typical method to solve any complex task or describe any complex structure is to decompose it into smaller, easily manageable units. The decomposition is useful for understanding the design task and allocating resources to it. The decomposition is defined as the breaking out of the product itself, not the process of design. The product development process includes a method that uses product decomposition. For example, House of Quality decomposes an emerging product into an engineering characteristic that contributes to the customer perception of quality. It is also identifying the function and sub-functions necessary to achieve the overall behavior defined by the product design specification. In this slide, we talk about physical decomposition. Physical decomposition means separating the product directly into its related sub-assemblies and explaining exactly how these components function together to produce the system behavior. Figure 4.1 shows the physical decomposition for the smart electric wheelchair system. We can see that there are 6 main assemblies in this system, which are controller, electric energy source, wheel, braking system, body, and smart system. Doctor may look into it for more details about all the components. So, we continue to functional basis. Functional basis is a tool for use in generating a function model in product design. The table below shows the table of standard flow classes of smart electric wheelchair system. There are 3 types of flow classes, which are energy, material, and signal. Doctor may look into it for more details. Next, we continue to systematic design. The system interacts with its user and uses the environment by exchanging the flow of energy, material, and signal with them. Figure 4.2 below shows the black box of the system. It started from human energy giving input signal as instruction and electrical energy as the power supply to give output in mechanical energy and kinetic energy as a motion thrust and directions. For the safety of the user, a smart system is installed in this electric wheelchair. This system includes an impact sensor and emergency button, which could sense impact and emergency situation and send out notification to the mobile application by using IoT. The functional structure block diagram used to represent graphical interactions between functions and another functions as correlation of input and output of the system, gathered with flow as material, energy, and signals. Figure 4.3 shows the functional structure block diagram of smart electric wheelchair system. The first part shows the flows of the electric wheelchair, and the second part shows the flows of the smart system.
4.5 Morphological chart. Morphological chart is a way to generate idea, to create concept based on the components that we want to include in our project. And here in our morphological chart, we have 14 components that we want to incorporate in our project. So in each concept, we have several ideas based on the available components that we are referring in the available market.
As for the context diagram, our wheelchair is divided into 5 elements. First is the user, second is the power supply, third is the environment, fourth maintenance, and lastly is the Internet of Things. And user is for the disabled people, and power supply will be dynamo as the secondary and rechargeable battery as the primary. Environment, we will use a clean and affordable power source system. For the maintenance is only when the wheelchair breaks down. And for the Internet of Things, we only uses impact sensor and emergency button, and return it will notify us through the mobile app. For the physics of design idea, the first is weight force identify. We need to identify, so we use the formula F equal to ma. F is known as the force, m is the mass, and a is the gravity acceleration. And second is our internal moment and forces in the wheelchair. We need to know the internal moment and forces in our wheelchair so that we will know where the shear stress and fatigue and so on occurs on the wheelchair. Next is the center of gravity. In order to find the correct balance of a wheelchair, we need to know the center of our gravity for the wheelchair. Lastly will be the characteristic of metals. Before we use any metals to create the body or the frame of the wheelchair, we will need to know the yield strength of the metals so that we can choose the right metal for our wheelchair. Thank you.
And this 4.8 is a concept design, and this is concept 1. This is concept 2, and this is concept 3, and lastly this is concept 4. If you may find to more details of the 4 concept, you can refer in a report.
As for the design parameters and constraints, we will make sure our design is ergonomic and will be concentrating on the sitting position, our arm places and our foot placing. For the safety, we'll be applying a seat belt and also we make sure safe harness installation. As for the sustainability, we'll be focusing on SDD7 for the power source and SDD9 for the Internet of Things. As for the reliability, we will be using mean time between failure for repairable products and mean time to failure for non-repairable products. We will make sure our wheelchair lasts long. As for the pocket-friendly maintenance, we will be using high-quality components and high-life batteries. And electronic components that we will be using, we will make sure it is cheap to replace. We will be focusing on materials which are light and will be opting out a light material for our wheelchair. Thank you.
Next, we will proceed to Chapter 5, Conceptual Design. This chapter discusses how to make appropriate decisions by using decision-making methods, namely the path chart and weighted decision matrix. Through this method, the final decision can be made from all the alternatives generated from the previous chapter. In decision making, we explain about decision influence both the direction of the process and the definition of the product. Decision makers adopt the decision making process to select the most logical choice from several existing alternatives. Decision making is classified into 4 groups. First is the decision under certainty. Each action results in a known outcome that will occur with a probability for 1. Second, the decision under uncertain. Each state of nature has an assigned probability of occurrence. The third is the decision under risk. Each action can result in 2 or more outcomes, but the possibilities for the state of nature are unknown. Last is the decision under conflict. The states of nature are replaced by courses of action determined by an opponent who is trying to maximize the objective function.
5.3 Part Concept Selection. Part method compare each concept relative to a reference or datum. For each criteria, determine whether the concept is better, poorer, or just the same as the reference concept. In table 5.1, Part Selection Chart 1, we take the best product in the benchmark to compare with our concept that we have come up, and we can identify which is the best concept. In this case, we have identified concept 1 is the best concept, so we can proceed with our project. In table 5.2, we take our best concept and compare with the others concept so that we can come up with the second best and the third best concept, which is concept 2 and concept 3.
In weight decision matrix, our team have divided the wheelchair into 3 types of sections. The first is the material, second is the functionality and performance. We have classified our criteria according to these 3 sections. And for the material, we have given importance of 0.25. As for the functionality, we have given 0.3. And lastly is the performance at 0.45. To find the best concept, we have done a comparison between the concepts. There are 4 concepts totally, and we have given the weightage according to the criteria. And as we can see, the concept 1 has the highest rating, which is 8.898, and it also scores the highest. So in a nutshell, concept 1 is our best concept since it fulfills all our need. Thank you.
Next, we continue to preliminary product design specification. The table shows the updated product design specification with the description based on the changes of the product specification. The product identity of this system is allow users to prepare the wheelchair more quickly and easily. increase mobility and independence for the user. And the key feature of this system is able to ensure the user safety by alert caregiver and family members during emergencies and accidents by using accident detection features and emergency button. It also contains dynamo, which is secondary power source, which is used to ensure not wasting any of the mechanical energy and convert it to electrical energy. For other details, Dr. may look into the full report.
And the last topic is a selected design concept. This is a best of selector of design concept. Best of 4 concept here. And then this is a draft team concept of the wheelchair. And the 4 specification in this project, the conceptual design one is selected as the final design project. Is selected due to making complex decision using weight decisions matrix and path chart concept selecting. Is selected because it uses a brake system to stop the wheelchair. In addition, it also uses a pulley and timing belt connected to a lead acid battery and high torque DC motor to move it. It uses a finger knob joystick to control the movement. It also has 2 footrest and handrest is used, so the user is more convenient in moving and use PVC ladder because it's more reliable and good in water and dust resistant. It's also use hub dynamo as a backup power in the event of an emergency. The frame material also use aluminum alloy because it is higher in weight and it has advantage of being resistant to corrosion. And it is used a tubeless tire because it don't have silly puncture lightweight and offer the ability to run lower air pressure for the better grip. It also use Arduino Uno and Wi-Fi model type ESP8266 Wi-Fi module. And lastly, it use a impact sensor to detect obstacles ahead, and an emergency button is used during emergency situation. And this is all of me and my team. Thank you.